Oh, good. Okay. So I guess everyone can hear me. Okay. Are there any questions so far? Yeah, I know we haven't done much yet, but if you have a question when I'm lecturing, I can't see the chat board, the chat, whatever you call it. You know, you can always, I mean, now I can, but when I'm lecturing, I can't. You can always use the hand raise feature. So, okay. Let's keep going. So that's our terminology. So, you know, it's good to see examples. In math, that's really, you know, it's good to see examples. That's how we learn. So the first example I have is we're tossing a fair coin, you know, twice, and we're recording what the coin lands facing up. You know, does it land heads up or tails up, that is. So this would be the sample space. H, of course, stands for heads. T stands for tail. And this would be our sample space. So this one occurs if we have heads, then heads. Right? Heads on the first toss, heads on the second toss. The coin lands heads up twice. We get heads, then we get tails from the coin. We get tails, then the coin lands heads. And, you know, here we get twice, two tails, that is. So from here, a simple event would be the event that, you know, the coin lands heads up, then tails up. That would be a simple event. You can't break that down any further. Or if you get tails twice, that would also be a simple event. An event such as the coin landing on heads exactly once. That is something you can break up because that can be done by getting this outcome or this outcome. So this event, the coin, oh sorry, not heads, tails, the coin lands tails up only once. So it never lands heads up. For this one, you know, that's an event that can be broken down. You know, you get heads, then tails, or tails and heads. This is just another event that it never lands tails up. Well, in that case, that's the same as as the coin landing on heads twice. So these are just some examples I thought would be good to do. Here's the one I was saying before. Suppose we're rolling a fair six-sided die, okay? You know, like in a board game or something. Well, maybe not in a board game, but still. The sample space, again, which is all possible outcomes, would be this. You know, each side of the die is labeled with a number. And then a simple event would be, like I said before, we're rolling a 1. That would be a simple event. Rolling a 2 would be a simple event. An event that's not simple would be rolling an even number. That can be done by rolling either a 2, a 4, or a 6. Rolling a number larger than 3, that's an event, and that's not simple. Because that can be done by rolling a 4, a 5, or a 6. You can break that down. You could break it down into, I hate to say smaller outcomes, but I guess I'll say that. Smaller outcomes. Hopefully it makes sense what I'm trying to say. Okay. So those are some examples. Hopefully you're starting to get the idea. I mean, probability I know is not easy. I understand that. So bear with me on this. Here's the actual definition of probability. We're assuming all the outcomes are equally likely. Actually, let me go back here. That's what we mean when we say a fair six-sided die. Each of these outcomes are equally likely. So you're just as likely to roll a 1 as you are a 5. I didn't list it here, but you can imagine tossing a fair coin once. You know, the coin landing heads up is just as likely as the coin landing tails up. It's not a, what do you call it, a two-sided coin. The die is not, you know, some specially made die where it's more likely to roll on 5 than 6. So. Then, if you have an event E, you denote events by capital letters, mostly because they are actually sets, and sets are denoted by capital letters. But the probability of event E occurring is this. It's the number of outcomes corresponding to event E divided by the total number of equally likely outcomes. You could also think of it as the number of outcomes that correspond to event E divided by the total number of outcomes in the sample space. I mean, again, we're assuming all outcomes are equally likely. That's what we're dealing with now. Okay. That's our definition. Well, now let's consider some examples. So let's say we're rolling a 6-sided die, okay? You know, from before. Even though I listed it already, it wouldn't hurt to list again. What's the sample space, right? You know the answers are down here. What's the probability of rolling a 2, okay? And what's the probability of rolling an even number? Well, we know that sample space, right? That's all the outcomes, and we have it listed here. These are all the outcomes you can get. Okay. I know we had that earlier. Okay, what's the probability of rolling a 2? Well, how can you roll a 2? There's only one outcome there, right? There's only one outcome corresponding to rolling a 2 itself. So we have 1 on top, right? There's only one outcome corresponding to rolling a 2, just rolling a 2. And then we divide by how many outcomes there are. There are 6. So it's 1 over 6. I mean, yes, you could write this as a decimal. In fact, you could convert this to a percent if you wanted to. But for now, let's just leave it as a fraction. What about rolling an even number? What's the probability of that? Well, how many events are there corresponding to rolling an even number? Well, we can roll a 2. That's one outcome. We can roll a 4. That can happen. And we can roll a 6. So there's 3 events corresponding to, excuse me, not 3 events, 3 outcomes corresponding to the event of rolling an even number. So the probability of rolling an even number, there's 3 ways that can happen. There's 3 outcomes, right? Rolling a 2, 4, 6, 3. And how many outcomes are there? 6. So we get 3 over 6. Now, I know some of you are probably thinking, do we have to write this in lowest terms? The book does, but personally, I don't think you should. I would just leave it alone. I think that the book, writing it in lowest terms, is really not what it should be doing, mostly because it can affect the interpretation. So I would not write it in lowest terms. I mean, if you happen to without thinking on a quiz or something, I'm not going to take points off of that. But personally, I would just leave it alone. That's one example. Okay. Let's build on that and consider another example. So here, this is now we're rolling a 12-sided die. I don't know if there is such a 12-sided die. And now, let's just assume that there is one. Okay, there might be a 12-sided die out there. I honestly don't know. So we want to know what is the sample space. We want to know what's the probability of rolling an 11? And what's the probability of rolling an odd number? Since this is a fair die, all the outcomes are equally likely. They're all equally likely. So the sample space, they listed it here. You know, the idea is that on each side, you have a number. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? That's our sample space. Okay? Now, what's the probability of rolling an 11? Well, how many ways can you roll an 11? Just one, right? You get the outcome 11. There's only one way that can happen. So because of that, the probability of rolling an 11 is 1 out of 6. There's only one outcome associated with rolling an 11. Rolling an 11. What about rolling an odd number? Well, I have the answer here, but let's see why. How can you roll an odd number? Well, you can roll a 1. You can roll a 3, 5, 7, 9, 11. So the 6 ways we can roll an odd number, right? There are 6 outcomes with this event. Rolling a 1, a 3, a 5, 7, 9, or 11. So the probability of that is 6 over 12. There's 12 elements in the 12 outcomes in the sample space. 6 ways we can roll an odd number. 6 outcomes, that is. So 6 over 12. I think rolling on 11, I made a mistake here. It shouldn't be 1 over 6. It should be 1 over 12. Okay? Because again, there's 12 possible outcomes, so it's 1 over 12. Let me just fix that. Sorry about that. Okay. There we go. Good. So that's a funny looking 1, I know, but it's 1 out of 12. Okay. All right. Anyway, so we have 1 out of 12. Okay, let me stop the recording again. Okay.